derivative from first principles once again. They give us f of x. We need f of x plus h also, which means everywhere there used to be an x, put x plus h instead. So we get 1 over x plus h squared minus 2, which is 1 over x squared plus 2xh plus h squared minus 2. Huh. That isn't factorable or anything, so I guess that's just all one big piece. And it means our derivative is the limit as h goes to 0 of f of x plus h, so that whole fraction, x squared plus 2xh plus h squared minus 2, minus f of x, and all that is over h. Now, we need a common denominator for all this, which means I'm going to need more room. The common denominator is going to have x squared minus 2 in it, so this fraction needs x squared minus 2's. That's not the rough part. The rough part is this fraction needs this whole thing. X squared plus 2xh plus h squared minus 2, top and bottom. Okay. Now we can combine these two fractions into one great big thing. We have the limit as h goes to 0, x squared minus 2. Now, this minus sign applies to everything that comes after. Minus x squared minus 2xh minus h squared plus 2. All that is over x squared minus 2 times x squared plus etc. And instead of over h, I'm going to put times 1 over h. We've seen that work before. Clean up. Minus 2 and plus 2 drop out. X squared and minus x squared drop out. And so we're left with minus 2xh divided by h is just minus 2x. Minus h squared divided by h is just h, which doesn't matter because h is going to go to 0, so that term just vanishes. All we get out of the top is minus 2x. And downstairs we have x squared minus 2 and x squared plus 2xh plus h squared minus 2. Now here also, I should have done this all at once, I apologize. H is going to 0, so these two terms vanish. And so our real derivative is minus 2x over x squared minus 2, and then this term is x squared minus 2 also, so we end up with x squared minus 2 all squared is our finished function, or our finished derivative, I should say. dy dx, our derivative, is equal to this. So if we just wanted the derivative, we'd be done. What we actually want is the derivative when x equals 2, so we can put that in. We get minus 2 times 2, and down here 2 squared is 4, minus 2 is 2, squared is 4 again. Minus 4 over 4 tells us the slope of the tangent line is minus 1. That's our second answer. And finally, they want the equation of the tangent line, meaning a line with a slope of minus 1 and that line has to pass through 2 comma 1/2, so we can use that to figure out our b value. Y equals minus 1x plus b, so b is going to be 2.5. And our tangent line is going to be minus 1x plus 2.5.